In this video, we're going to talk about force. As much fun as it would be to do a video just talking about Star Wars, in this case, we're going to talk about force as it relates to physics. The definition of force is a push or a pull on an object. Force is a push or a pull on an object. Now you can see just from these pictures that we're dealing with how much force is being applied, but we're also dealing with a direction. So force always has a direction. You can see which direction these forces are being applied. So the formula for force is equal to mass times acceleration. And F is always written as a capital, M and A are lowercase. So this is force, mass, and acceleration. You don't have to have that memorized. It's going to be on your formula chart. I think you're going to find that you memorize it anyway. So just to go over, since we have a formula now, we have F equals ma. Let's make sure we know what all of those are. So what is a force? We just said it's a push or it's a pull. Now what units are we going to write force in? Okay, force is measured in newtons. Okay, these are newtons. Now, I'm going to tell you that a newton is also known as a kilogram meter per second squared. Now, that may mean nothing to you right now, and if it doesn't, that is perfectly fine. We're going to come back to that later on in another video and explain that in some more detail. So, what we need to know right now is force is measured in newtons. What is mass? Okay? Well, we know that mass is how much matter there is. All right, we've been studying that since we were probably in grade school. All right, and so what units do we measure mass in? We're going to measure mass in grams or kilograms. We're going to find when we do physics is we much more frequently use kilograms. And then finally, what is acceleration? It's a word that we use a lot in our day-to-day life. That car is accelerating, but we haven't really talked a whole lot about it scientifically. Acceleration is a change in speed or a change in direction. Both of those would be an example of acceleration. So if you were to hear a talk about a car changing its lanes, that would be acceleration because it's changing its direction. Or if it turned to the left, if it speeded up or it slowed down. Okay, the unit for acceleration is meters per second squared. Now, if you aren't familiar with that, don't worry. Again, we're going to come back to that later on. Let's take a look at a sample calculation for force. Again, let's remember that the formula equals force equals mass times acceleration. So in this case, it says the ball is accelerating 10 meters per second square to the right. So we're going to write down our given. It's always a good habit to do that. 10 meters per second squared. Its mass is 20 kilograms. Notice I'm not just writing 20 kilograms, I'm writing what it is. A equals M equals. We don't know what force is. So let's say we want to find out what is the force acting upon this ball. We would know that force is equal to the mass, which is 20 kilograms, times the acceleration, which is 10 meters per second squared. So the force, 20 times 10 is 200. And kilograms times meters per second squared would give me kilogram meters per second squared. You have to trust me on that one, or we would just know that it would be 200 newtons. Let's take a look at another way that this formula could be used. So in this case, I'm going to write down the formula again. Force equals mass times acceleration. But here you can see we were given the force and the mass, and we were asked, what is the acceleration? How much was this block speeding up? So what we're going to do is we're going to just fill in what we know. This 100 newtons, we're going to fill in on the force side because that's the same thing. Force is equal to 100 newtons. Equals mass. We know the mass is 1,000 kilograms. And we don't know what acceleration is. Now we know from math that we want to try to get acceleration by itself. So we're going to divide both sides by 1,000 kilograms, right? And we know that if we have a number on the top and a number on the bottom, they cancel out. Same thing, the kilograms cancel out. We know that those zeros cancel out. Those zeros cancel out, and we're left with 1 over 10, okay? Acceleration equal to 1 over 10, which is the same as 0.1 newtons over kilograms, or 0.1 meters per second squared. Now, if you don't know how we made this jump, that is perfectly okay. We're going to explain that in a later video, but just trust me that acceleration is measured in meters per second squared. So when this man is pushing this very heavy block, he's not able to make it accelerate all that much. That kind of makes sense. Let's test that out over here with a smaller block. Force is equal to mass times acceleration. And now we're having 100 newtons of force equals the mass of 100 kilograms. And we don't know what the acceleration is. So again, we want to get acceleration by itself. So we divide it by 100 kilograms over here, by 100 kilograms over here. And again, now we're able to cancel out. The kilograms cancel out, the hundreds cancel out, the hundreds cancel out over here. And so we're left behind with acceleration equals, in this case, 1, because everything's canceled out, newtons per kilogram, or acceleration equals 1 meters per second squared. And does this make sense to what we know in real life? Is it easier to make a small, lighter block, a block with less mass, speed up than it was a big block? That's absolutely true. It's hard to push something heavy. It's easier to push something light. So in summary, a force is a push or a pull in a specific direction. The formula for force equals mass times acceleration. When we talk about the units that are going to be important in this formula, we have a Newton is a unit of force. It's also known as a kilogram meter per second squared. Kilogram in meters over second squared. The unit of mass is a kilogram. The unit of acceleration is a meters per second squared. If these don't make sense to you yet, that's okay. We're going to get there. And as we would expect, we demonstrated with a formula, the more mass that an object has, the harder it was to make it accelerate or to make it move faster.